Good day, ladies and gentlemen, and welcome to the Peering 101 webinar conference call. My name is Jessica, and I will be your coordinator for today. At this time, all participants are in a listen-only mode. We will be facilitating the question and answer session over the web portion today. If at any time the call requires assistance, please dial star, then 0, and a coordinator will be happy to assist you. I would now like to turn the presentation over to your host for today's call, Ms. Lauren Starr. Ma'am, you may proceed.
Thank you, and welcome to today's webinar, Peering 101, presented by TELEHOUSE America. This is meant to be an interactive session, so questions are welcomed and encouraged. Should you have any questions that come up during the presentation, you can use the chat feature located on the bottom right-hand corner of the screen. Type your question into the text box and click the drop-down menu to send your message to the host by selecting Submit. Only the host will be able to see your questions. I'd now like to begin by introducing today's speakers, Fred Cannone, Director of Sales and Marketing, and Akio Sugeno, VP of Internet Engineering and Operations of TELEHOUSE America. I will now turn the event over to you, Fred.
Thank you, Lauren. Thank you, Jessica. Appreciate your help on this. I would like to welcome everyone joining in today. It's a beautiful day in New York. And of course, whenever it's a beautiful day in New York, it's always a great time to talk about peering. We especially want to quickly review some of the agenda items, although we'll probably cover a little bit more than this, depending on time. We want to do some introductions, clearly talk about the purpose of the webinar, what is the Internet, what does Internet traffic mean, and ultimately, how does it all work in terms of ISPs connecting, Internet routes, how do they work, transit versus peering, and of course, what does a well-architected network look like? So we'll get to each one of these, and of course, ultimately your questions, time permitting. We want to start with basically just talking a little bit about what was the purpose of doing this. As many of you know, TELEHOUSE does have, TELEHOUSE America operates the NYIIX as well as the Los Angeles Internet Exchanges. And so we have quite a following in terms of telecommunications, ISPs, and content and application service providers. But what we've been finding lately is that there are a number of customers that, while having large amounts of Internet traffic, were not familiar, have not been familiar with peering, and so we introducing this series to do two things. First one is obviously educate folks on the fact that what is peering and clearly what a valuable network resource it is. Keep folks informed about developments with this valuable resource, and obviously what is the utilization of this? Does it apply? Oftentimes, when I start talking to folks about peering, they sort of look at me with a puzzled look, as if that didn't apply to them. Well, the fact of the matter is this can be utilized by everyone, and specifically not just the large ISPs or telecommunication companies. And obviously that it provides additional resources for people, not just from a network architecture point of view, but clearly from a cost and utilization aspect of their existing resources. So we certainly want to keep this program up, and obviously with each one that we'll do, we'll get a little bit more sophisticated in terms of the level of discussion and certainly the level of introduction of the material. But for this session, quite frankly, if you're an existing large ISP and maybe even join ours or other large peering platforms, this probably isn't for you. But certainly we're welcome to any questions and issues that you may have, or if there's any material that you're not familiar with. So thank you again, everyone, for joining in. So we'd like to start today by very quickly just introducing who we are. If you're not familiar with TELEHOUSE, essentially TELEHOUSE is a carrier-neutral data center provider. Currently, we have about 41 data centers across 10 countries right now. Our parent company, at least 66% of us, is owned by KDDI of Japan. Total consolidated revenues of roughly $34 billion. And these days, we've become a total IT solution provider. And with regard to peering, currently TELEHOUSE America specifically operates NYIIX, which we created in 1986, and the Los Angeles Exchange, which opened up in 1998. But technically, my understanding is about 95% of all telehouse facilities around the globe have some form of a internet peering entity, whether it be operated by Telehouse or some other party. So we'd like to start today by just basically reviewing, and this obviously is probably not news to most folks here, but what is really the internet, because I think that's really where the whole issue of peering starts. So very quickly, as most of you know, it's not a single network. Clearly no one owns it or administers it in terms of its entirety. Currently, or at least as of November of last year, I guess when we took last count of this, there was over 36,000 ISPs globally. And just to define that, what that meant is that there are 36,000 essentially autonomous networks. And that the internet, almost by definition, is the collection of those multiple, or is the multiple autonomous network that somehow gets connected and ultimately works. So of that, what is internet traffic? Well, essentially using BGP, or the language of interconnection these days, which is border gateway protocol. Essentially, people can communicate over the internet. They can essentially send each other pieces of information. So you typically can have somebody with one ISP. I know my kids at home are busy either surfing the web or, of course, doing their thing with Facebook and YouTube, and are communicating, obviously, via that embedded BGP capability over our local ISP with other folks, again, on the internet, who may not necessarily be part of the same ISP, or obviously on other ISPs, especially with different geographies. So essentially, it's the exchange of internet traffic between two ISPs. So how do these ISPs essentially connect to each other? Well, really, there's only two choices. The first one is transit. And transit essentially means that they provide full global internet routes or access to all IP addresses. And obviously, we all pay for this. So whether you're at home or a company, typically you're buying, in one way, shape, or form, access to the internet. And that's typically transit. The alternative is peering, and peering essentially is a partial, or provides for a partial access to internet routes or a limited number of IP addresses based on the partners that are actually involved in the peering or exchanging traffic. That the graphic sort of gives you a picture of obviously transit being the whole, in this case the moon, and obviously peering being the sliver of it. So to understand where we go from there is we need to understand basically a little bit about how all this literally works. So what are internet routes? Well, each of those ISPs that are either going to be using transit or peering are identified or have a code name, and that is the ASN number, Autonomous System Number, and they own routes, or essentially IP addresses. An IP address acts similarly as zip codes do for a typical street address when we're sending mail or shipping boxes. And a typical, excuse me, IP address looks like that 12-digit, 10-digit number, and each sub-address, technically, or subnet, up to that /24 could potentially the IP addresses for up to 254 addresses. So this sort of gives you an analogy between what a zip code typically would look like with a street address versus an ISP's ASN number and essentially IP address spaces that it controls or owns. So how do these internet routes work? And so we're going to take each side of that equation separately. So first we're going to start with the inbound. So in order for an ISP to receive traffic, essentially they have to announce using the BGP or Border Gateway Protocol all of its routes, all of the addresses that we just quickly reviewed, to the Internet in order to receive that traffic. So I hope that's pretty clear. Thanks to Akio, he was able to really make this as simple as possible. And on the flip side, which is basically the outbound side, in order to send traffic, ISPs essentially must have full routes announced, their full routes announced, again using BGP to the Internet, and they have to keep those routes, routing tables, up to date in order to ensure that their clients have the global reachability that they're all looking for. So once that's done, or information comes in, essentially routers, both ends of these, ultimately have to make routing decisions based on the tables that they've either sent out or certainly received. So ultimately, just to recap then, so the difference between transit versus peering is that transit technically has access to all the routes. There is a cost relative to what it is that you're buying in terms of size and obviously geography, as well as who the actual ISP is. And typically, only the large providers or typically tier 1 providers, typically telecom, big telecom providers, provide or have access to the full routes, as opposed to peering, which is partial routing and ultimately free. Not exactly free, but we'll get into it in a little bit in a minute. So the best architecture, or the best network configuration that an ISP, or for that matter, really, anyone who's pushing traffic these days, would want to combine both elements. They'd want to combine transit and certainly peering to optimize their network configuration. So how does that actually look? How does an ISP, and ultimately us, you as a client, operate, or how does a well-architected network connect to, or should connect to, the Internet? Well, ideally what you want to do is you want to minimize the amount of traffic, or bits, obviously, that you're pushing over the transit or paid portion of your bandwidth, and ultimately try to maximize the amount of traffic that you're pushing over your peering capability. So this diagram sort of gives you a standard ISP architecture, and again, it's probably a pretty good model for most of us. So starting in the middle with the ISP, obviously, would route transit, which is obviously paid for, over those full routes through a tier 1 ISP. On the flip side of that, obviously, where we have partial routes, we'd want to send as much traffic as possible over to what's designated here, at least in the diagram, to more regional or local type routing or IP addresses. So essentially then, what is the definition of peering? Well, to put simply, it's settlement-free exchange of Internet traffic, where both parties ultimately agree to move that traffic over each other's networks without any formal monies or credits exchanged them. So the benefit clearly at this level is transit costs money, peering is basically free, so ultimately you're saving, or at least in the big scheme from a budget perspective, averaging down your cost. So why peer? Well, let's review it. So again, we talked about being free, but actually what it's really doing is you're averaging down your total transit cost. It's certainly giving you new routing options in order to route your traffic. And then obviously it has some additional benefit in terms of latency issues. As you can see from this diagram, if you want to reach certain routes over your tier 1, that it might actually take a little bit longer to get there, as opposed to if you were resourceful and were on the right peering exchange or connected to the right peers, you could actually get there a little faster. In this case, the target being ISP-C, so you can see that technically, even over a large tier 1, there may be some additional hops, which causes a delay in obviously your signal getting to that one particular either ISP or, for that matter, their sub-address. So who appears and who benefits? Well, obviously, as we talked about at the top of this presentation, obviously large ISPs and businesses are already doing it, and clearly they do it because they can more readily get access to both niche as well as regional traffic. But increasingly, and ultimately the point of this session is to talk to more of the small to medium-sized network traffic type businesses, which is, you, in order for you to gain more access to both mainstream traffic as well as niche and regional traffic in a more cost-effective and certainly, hopefully, a more efficient way. So again, benefits. So again, just to review, one of the things that we certainly hope to gain is improved connectivity. And this is done, obviously, by connecting over a layer 2 switch in the case of a peering exchange. We talked about averaging down bandwidth costs. And then, of course, as we mentioned, again, in discussion of how it all works, this provides routing options for us in order to gain diversity of routes and certainly of traffic so that we are no longer restricted in terms of just paid bandwidth and the routes that the paid bandwidth network might take. And again, the whole point of this is that this isn't just for ISPs and large telecommunication providers. Now, you should be aware that there's different peering types. There's both bidirectional and unidirectional. Typically, bidirectional is between tier 1s or very heavy ISPs that have a lot of traffic. Then unidirectional is typically folks that are delivering specific content to the mass audience. And here's typical examples. Bidirectional, where you have two large telecommunication providers, in this case Verizon and KDI, exchanging perhaps North American traffic with some Asian traffic. And then in the unidirectional sense, where we have YouTube with obviously content heavy delivering to the home, in this case perhaps locally Time Warner cable clients. Additional peering types to be aware of is both bilateral and multilateral. So bilateral peering is typically between two ISPs. Essentially, it's directly one-to-one. Multilateral is among many, one to many. And again, the example is, in this case, where AboveNet and Microsoft actually agreed to peer directly with each other, as opposed to, in the case of multilateral, where you typically are using a peering exchange, and typically a peering exchange would have, or members of it might have an open peering policy. So one ISP technically via route servers, for example, in the case of NYIIX in Los Angeles Internet Exchange, we have our own route service to assist the ISPs to move that traffic to multiple ISPs. Did you want to make a comment on this, Akia? Okay. Jump right in anytime. And then lastly, obviously both private and public peering. Again, private is directly between two ISPs literally connected over cable, fiber, or otherwise, versus public. Again, public is typically over an internet exchange point that's operating a layer 2 type switch. So, and most of those, we have about 300 known internet exchange points in the world. I'm sure since we did our research, there may be one or two more that have opened up. These internet exchange points are operated by profit or non-profit organizations. And typically what we found, not only in our own case, but even in the case of most of the large internet exchange points, that carrier neutrality is really a key to the success of that capability or that resource. So just to describe a little bit about what a typical public peering platform looks like, it is a layer 2 switch. That's typically today's mainstream configuration. They peer over the same broadcast domain, or I guess that VLAN might be a better way of putting that. But Akia, did you want to make a comment on that?
Basically, this is like you're on the same switch, and the multiple people are talking over the same switch. That's
okay. All right. And of course, there are optional route servers for multilateral peering that are available if the peer doesn't have the ability nor the desire to do that on their own. A little bit of additional definition of a public peering platform on that layer 2 switch. Typically, this has been the platform that's proven pretty consistent, at least in our case, for the past 15 years, approximately. The peering protocol, which we talked about earlier, BGP, does require or clearly works with an L2 switch. Another advantage, or certainly capability of the public peering platform using an L2 switch is that the 10G port speeds these days is guaranteed. There are options in terms of jumbo framing. There are options in terms of VLAN availability for private peering. And in its current configuration, the machines, the switch itself, as well as the most of it, certainly the fiber cabling associated with it, can or is scalable up to 40G and perhaps 100G, depending on makes and models. The next three series of slides probably gets into an additional layer of complexity in terms of the discussion of the public peering exchange operations, which I think we're going to pass on this time and go directly to our developments, where we see the peering platform going in the future. So where we see it going ultimately is to more of an MPLS-based peering. This was originally proposed back in NANOG and back in 2002. In fact, if I'm not mistaken, you did, Akio. So it was pretty creative, obviously a man before his time, okay? And certainly with that, the whole capability of MPLX router-based peering exchanges no longer an L2 switch. Do you want to make a comment on that, Akio? Any additional comments? Or talk about what you see as the features and benefits.
Benefits are written like take your tunnel per peering session, meaning based on the MPLS platform, every peer can be segregated from the other peers. So no other customer members can see or send the traffic to that peer. So it's like they have their own route, private,
Understood.
Right. Also, every peer has their optimal MTU, maximum size of packet. So if you have your large or a high performance router, you may want to choose jumbo frame like a 9,000 bytes per frame. That will be pretty optimal. Also, you can see the traffic per peer. So if you were, say, regional ISP peering with Google or Microsoft or something, you want to see how much traffic you are sending to or from Google, Microsoft, or other peers. You want to see per peer basis their statistics. So it can be happening. Also, traffic engineering. With L2 platform, if you have the ring configuration or something, you will always end up with the L2 program. Then you enable the spanning tree, but refreshing is slow, and you're not using the existing feedback path because you are logically deleting a path to avoid L2. But however, with MPLS, you can have the traffic engineering part, meaning you can fully utilize all ring configuration, and you can prioritize or whatever per your customer's needs.
Well, thank you. Well, this clearly is probably more of a subject that we could get into at a later date, maybe in the Peering 102 or maybe even the Peering 103 session. But certainly want to bring everyone up to date on what the future, at least as we see it going forward, that will probably be more MPLS-based than certainly the L2 platform is today. And I apologize, but this gives you a sense of who, at least in the case of the New York Internet Exchange, NYIIX, we have a bunch of ISPs, or what we like to call XSPs, which consists of carriers, ISPs, content service providers, application service providers, all exchanging traffic via the New York International Exchange, NYIIX. So we'd be delighted to talk to anybody who, or exchange some additional information with anyone who wants to get a little bit more granular on this. In fact, you could go to the website and actually pull off the list yourself at www.NYIIX.net. So again, for NYIIX benefits at least, we do have, this is available via a variety of different locations. In the case of NYIIX, certainly it is available from our 25 Broadway, our new Chelsea facility at 85 10th Avenue, certainly the teleport in Staten Island, and also in the case of New York, 60 Hudson and 111 8th Avenue. Our Los Angeles Exchange is available in our co-location at 626 Wilshire, but it's also available via the core site's 1 Wilshire facility. And just to give you a sense of who else is out there, obviously we have our own sort of self-interest here from a NYIIX point of view, but you should be aware that this is a pretty popular and clearly useful resource that exists not just here in the United States, but it's very, very popular overseas. In fact, most of the largest ones do operate overseas. The largest one, I believe, in the world is AM6, the one in Amsterdam. So this gives you sort of a, I don't know, 2, 4, 6, roughly a top 8, although it's a little bit difficult to qualify. But nevertheless, these are some of the peering exchanges that exist globally, and we would encourage you to, if you are or can take advantage of these resources, we would encourage you to do so. Additional resources from a pure engineering capability and a review of the subject, there's certainly training capability. The ones that we most are familiar with are the NANOG and RIPE. NANOG is the North American Network Operators Group. They hold meetings twice a year in a variety of different cities here in the United States. And then RIPE is the European counterpart of that. Again, they hold 2 sessions a year, again in a variety of European cities. And these are very technical sessions where a complete thorough review, a really granular review of network configurations, hardware configurations, et cetera, are reviewed and in many cases tested. So and it's a good time, obviously, to network with these engineers who, at least from my humble perspective, are kind of running the planet these days. So it's quite a group of people. So we want to, did you have any other comments, Akio, that you wanted to make before we close, or at least move on to questions and answers? Anything you wanted to
No, but I like to hear their questions.
Oh, okay, good.
That was,
Okay, great. Lauren?
Yeah, we have a few minutes remaining, and both Fred and Akio would be happy to answer any questions you may have. So please feel free to type your questions in the chat window below. It looks like we've already had a few that come in, so I'm just going to start to read these off. Will a peering exchange like NYIIX ever reach a limit for the number of companies and ISPs that can connect?
yes. Yes. They can peer at the NYIIX, and as we explained, usually peering decision is made by the members. So if their members are like open peering policy, they will peer with you, with anybody. If they have a policy-based peering you have to meet some sort of requirements to peer with the members.
Yeah. So, and just to complement what Akio just said, technically the answer is no. The only real limits, real limitations are, first of all, from the capability of the actual layer 2 switch, and at least in this case, a layer 2 switch. So obviously all of these switches, depending on manufacturer, et cetera, have or come with some pre-configured number of slots or ports that are available, whether they be GigE ports, whether they be fast Ethernet ports, or for that matter 10G or other sizes. So there is just purely a physical limitation, but again, the great thing about these boxes, or at least the manufacturers these days, is that they're making them more scalable so that as more people want to peer or occupy ports, you could just add to it or upgrade the box to whatever the next size box. In addition, the only other physical limitation would be, at least in the case of NYIIX and similarly configured peering exchanges that operate in multiple buildings. Okay, so for example, in the case of NYIIX, as I mentioned, we're available both at 25 Broadway, 60 Hudson, 7 Teleport, Chelsea, so the 5 buildings essentially in New York. So if there were some limitation in terms of what the capacity was between those buildings, whether it be dark fiber or other lit service that somehow restricted the traffic. So from a physical point of view, the answer is, well, it's as much as the box or lit or dark fiber will hold and the optics associated with that. And from a policy standpoint, as Akio said, it's limited to the peering policies of the actual members or participants themselves. In the case of open peering policies, essentially, a simple email or a call between them and they can start exchanging. For those that are a little bit more structured, there may be an agreement that somebody physically has to sign, or they may have to meet certain criteria in terms of volume of traffic or the type of traffic that it is. And I could just tell you that in the case of our peering exchanges, both NYIIX and Los Angeles Internet, I think 98% roughly are open peering policies. I would say 80. 80% these days? Okay. 80% is, Akio qualifies, 80% is more open, and the balance having a more structured peering policy. I remember when I first started 7 years ago, it was probably 98, 99% open peering, but obviously over time, people are getting a little bit more quality oriented. So, any other questions?
Yes, this one's actually come through the chat window. With today's peering, what are the security risks and what type of traffic are people sending over peered lines today?
Okay, with regard to security, the IP address space on the exchange point is not announced to the Internet. That means nobody can reach, ping to Internet exchange. That's security policy. So it's kind of safe. Also, regarding the traffic, we do not know, but usually all content provider has, HTTP or web or Twitter or whatever. Any traffic will go through the exchange point, even like a voice, like a 911 call over VoIP.
Great. Here's another one from the chat window. Do you see small and medium businesses being able to justify the use of networking requirements for peering, specifically assignments of routable networks via IPv4 from ARIN?
Yes. To peer with at the exchange point, you must have minimum flash 24 address space. Probably you already know that's the minimum requirement to announce your route to the Internet. And if you have meet the kind of requirement, and you should be able to appear with some of our members at least. Yes.
Sure. Yeah, this is interesting enough, and ultimately one of the reasons why we did this is because we have some clients that pretty sophisticated internet clients these days, that we were a little surprised to learn that they weren't familiar or too familiar with public IP peering. And so in many ways that was encouraging, but it was also kind of disappointing in the sense that, here's a perfect opportunity for these companies to be utilizing their resources a little bit more effectively and weren't. So we clearly helped them to do that. So yes, and these are small to medium sized, and so one might argue, well, how small? Well, not quite sure. But ultimately, the three benefits that we talked about, which is A, averaging down your bandwidth cost, B, providing diversity in terms of your routing, and C, capable of improving essentially your network connectivity, whether it be latency or, for that matter, just the quality, the reliability of that connection. That ultimately translates, depending on the size of the company, to dollars and cents, okay? Dollars and cents in terms of downtime, dollars and cents in terms of diversity, dollars and cents in terms of actually saving money. I know with New York Internet Exchange and certainly with Los Angeles, and I'm sure with all of our competitive exchanges, everybody's sort of operating the same principle, which is they're looking to maximize how they move that traffic. In some cases, I know we have one very small internet peering client on NYIIX who I think does less than 10 meg, okay? But because the preponderance of that is to like a handful of companies, they've chosen to route most of that traffic to those companies because it's direct, meaning it's not going over the public cloud anymore. It's literally going directly to those peering partners. So in that case, it's purely a quality issue. It's not, he's not really not saving a penny. Actually, he's probably paying more than he probably should. But because they value, in this case, the quality and the relative security of that, then it's worth their while. Any other questions?
Well, great. Well, it looks like we're just about at the end of the webinar. Thank you, everyone, for joining. You will receive an email shortly with access to view an on-demand version of this webinar for easy reference and playback. Should you have any additional questions, please feel free to email sales@telehouseamerica.com for more information. Thank you again for joining us, and we hope you have a great day.
Thank you, Lauren. Thanks to all.
Thank you very much.
Thank you for your participation in today's conference. This concludes your presentation, and you may now disconnect.